Welcome to the DIY Honda Garage channel. DTC P2229 indicates a high voltage issue within the BARO sensor circuit. The BARO sensor, or barometric pressure sensor, is crucial in measuring atmospheric pressure, providing valuable data for the vehicle's engine control module, ECM. The information helps the ECM adjust fuel injection and ignition timing for optimal performance. Located in the engine compartment, often near the intake manifold, the BARO sensor is connected to the powertrain control module, PCM. This DTC can be triggered by various issues related to voltage levels in the circuit, making it essential to understand how the sensor operates and interacts with the PCM. Proper functioning of this sensor is critical to ensuring that the engine runs efficiently and that emissions remain within acceptable limits. The BARO sensor plays a vital role in measuring the atmospheric pressure around the vehicle. This pressure data is transmitted to the engine control module, ECM, which uses it to compute the optimal air-fuel ratio and adjust engine performance accordingly. Typically situated in the engine compartment, this sensor can directly influence vehicle operation. A high voltage reading indicates that the circuit may have excessive resistance or a short, which can lead to DTC P2229 being set. Understanding the exact role of the BARO sensor is critical, as it ensures that the engine can adapt to changes in altitude and weather conditions. The gathered pressure data is represented in kilopascals, kPa, or volts, making it easier to diagnose problems based on the voltage readings. One potential cause for DTC P2229 is inaccurate readings from the BARO sensor, possibly due to sensor malfunction or environmental factors. Poor or loose connections, especially at the PCM, can lead to erratic voltage readings, making it essential to inspect these connections carefully. Another cause may be a faulty powertrain control module, PCM, especially if it is not functioning correctly or if it requires updating. If the PCM is outdated, it might misinterpret signals from the BARO sensor, leading to a high voltage reading error. It's critical to thoroughly check these components and connection integrity, as they directly affect the readings sent to the ECM and consequently the vehicle's performance. When DTC P2229 is triggered, one of the most noticeable symptoms is the illumination of the check engine light, CEL, on the dashboard. This alert indicates that there is an issue that requires immediate attention. Another common symptom can be poor engine performance. Customers may notice a lack of power or stalling, particularly under heavy acceleration or high load. Additionally, increased fuel consumption may occur due to improper fuel-air mixture adjustments resulting from inaccurate BARO readings. If the ECM is unable to correctly adjust fuel delivery based on faulty information from the BARO sensor, this can lead to engine inefficiencies and significantly impact fuel economy. Recognizing these symptoms early can assist in timely diagnosis and correction of the underlying problem. The first step in troubleshooting DTC P2229 is to ensure that the ignition is set to the on/to position. This allows the vehicle systems to initialize and become ready for diagnostics. At this stage, it is essential to record all freeze data and any onboard snapshot, since this information may provide insights into the conditions under which the DTC was triggered. Following this, reviewing the general troubleshooting information is crucial to understand specific guidelines and requirements before you begin further diagnostics. Each step builds upon the previous one, ensuring that no potential issues are overlooked. Proper diagnostics not only make the repair process more efficient, but also minimize unnecessary parts replacements. In the second step, you will need to check the BARO sensor readings in the data list using the Honda Diagnostic System, HDS. It's important to determine if the obtained value aligns with the expected specifications for the specific PCM type. For Keihin PCM, the reading should show about 160 kilopascals, or 4.49 volts or less. For Continental PCM, it should be about 120 kilopascals, or 4.95 volts or less. If the readings are within these limits, you should proceed to the next step in the troubleshooting process. However, if the values exceed these figures, it indicates an intermittent failure, meaning the system is currently operating normally. This step is fundamental as it directly verifies the sensor's functionality against preset thresholds, paving the way for a systematic troubleshooting approach. In Step 3, if the BARO sensor data does not reflect the latest software version within the PCM, the next action is to update the PCM software. Updating the software can resolve underlying issues related to software bugs or mismatches that may affect sensor readings. Should the PCM update not rectify the issue, substituting a known good PCM is recommended. This step helps determine if the problem lies within the existing PCM or elsewhere in the vehicle system. After implementing this update or substitution, recheck the sensor's data to evaluate any improvements. Proper evaluation ensures that each possible cause is examined thoroughly before concluding the repair process, thereby enhancing the reliability of the vehicle's performance. The fourth step involves checking for both pending and confirmed DTCs using the HDS. This process will help indicate whether DTC P2229 is still in effect or if other codes are present, suggesting different issues. If DTC P2229 is still present, it is crucial to inspect the connections and terminals at the PCM for any signs of looseness or corrosion, which could disrupt the signal being sent from the BARO sensor. Should you find that the PCM was updated but still shows the DTC, substitution with a known good PCM will help determine if the original unit was faulty. Conversely, if no errors are found post-substitution, you should return to the initial testing stage to confirm the BARO sensor's continuous performance and integrity. After completing the troubleshooting steps, the final repair verification process begins. First, you should check that the BARO sensor functions correctly and delivers accurate readings to the ECM. This step is followed by a thorough inspection of all connections to ensure there are no loose or corroded terminals affecting the electrical circuit. If everything checks out, conducting a road test is essential to validate that the repair resolved the issue and that the CEL light has remained off. These actions confirm that the vehicle systems are functioning properly and reassure both the technician and the vehicle owner. Final verification is crucial to ensure that no underlying issues remain unnoticed, thus enhancing the vehicle's overall reliability. Preventive maintenance is key in avoiding future occurrences of DTC P2229. Regular updates to the powertrain control module PCM software are fundamental to keeping the vehicle's data processing accurate. If the PCM software is kept up to date, it can more effectively interpret sensor data, thus avoiding potential malfunctions. Additionally, routine inspections of the electrical connections at the PCM and sensor can help catch issues before they escalate into significant problems. It is advisable to periodically monitor BARO sensor readings during regular maintenance checks, ensuring they remain within specified limits. By implementing these preventive measures, you contribute to the longevity and reliability of the vehicle's performance. reducing the likelihood of diagnostic trouble codes in the future. In summary, DTC P2229 highlights a crucial aspect of the vehicle's functionality regarding the BARO sensor and its circuit. Understanding the function of the BARO sensor is essential, as it directly impacts the engine's performance. By following the outlined troubleshooting steps, technicians can effectively isolate the issue and implement necessary repairs or updates to the PCM, ensuring that the vehicle undergoes appropriate preventive maintenance, including routine inspections and preventive updates, enhances not only reliability, but also long-term performance. The successful resolution of DTC P2229 exemplifies the relationship between maintaining a vehicle and optimal performance. Each of these elements works together to ensure that owners enjoy a well-performing and efficient vehicle. Please like and subscribe to the channel. See you next time.